Now in this question, we are given four masses M1, M2, M3, and M4 with 100, 175, 200, and 125 kilogram respectively, which are fixed to the crank of 200 millimeter radius and revolve in planes 1, 2, 3, and 4 respectively. The angular positions of the planes 2, 3, and 4 with respect to 1 are 75, 135, and 240 degrees, taken in the same direction or in the same sense. Distances of the planes 2, 3, and 4 from 1 are 600 mm, 1800 mm, and 2400 mm. We are expected to determine the magnitude and position of the balancing masses at radius of 600 mm in the planes L and M, located in the middle of 1 and 2 and in the middle of 3 and 4 respectively. So that's to tell us that the planes L is located between 1 and 2, and then the plane M is located between 3 and 4. So now solution, we draw this table just to save our time. I've already done the table. So the masses 100, 175, 200, 125. So we don't know the mass M5 and also don't know the mass M6. So we've been given the radius from the crank as 200, 200, 200, 200 for the first four masses. But the last two masses, that's M5 and M6, which are the balancing masses, we have the radius as 600 and then 600. So for us to get this third column, you know your centrifugal force is given by M omega square R. So MR is the same thing as FC over omega squared. So that is, you multiply 100 times 200, you get 20,000. 175 by 200, you get 35,000. 200 by 200, you get 40,000. 125 by 200, you get 25,000. M5 by 600, you get 600 M5. M6 by 600, you then get 600 M6. So now we draw the space diagram. From the question, we're told that M1 is the reference angle for other angles. So this is our M1. We have this as our M1. And then the next one is M2. And M2 is at an angle of 75 degrees. So 75 degrees about this place. So this is 75 degrees. And then M3 is at an angle of 135. So here is 75 degree. Here is 135 degree. And this is M3. And then M4 is at an angle of 240. So here is going to be 180. So 240 is going to be somewhere here. So this is M4. And then the angle here is 240 degrees. So this is our space diagram. So also we have masses M5. And then we also have M6. So we don't know the angles of M5 and M6 yet, so that's why we use hidden lines here. So also we can draw our plane position diagram. So we have this as plane 1, we have this as plane 2, this is plane 3, and then plane 4. So in between 1 and 2, we have plane 5, and then in between 3 and 4, we have plane 6. So now, from the question, we are told distances of the planes 2, 3, and 4 from 1 are 600. So it means between 1 and 2, the distance is 600. Between 3 and 1, the distance is 1008. And then between 4 and 1, the distance is 2400. So this is the plane or position diagram. So now back to the table. Now going to the fourth column. We have to go to the fourth column because now looking at the third column, here we have a mass of M5, we have a mass of M6. Now we also have an unknown here. We have an unknown. It means we also have two unknowns, two other unknowns, which are the directions of M5 and M6. So that means we have four unknowns just in this column. Since we have four unknowns just in this column, it means it's impossible for us to use a false polygon to be able to find the unknowns. So it means we have to move further to have our couple polygon. But before we get the couple polygon, we need to determine the reference plane. So this fourth column, we have distance from RP. RP means reference plane, which is in millimeter. So this is in kilogram millimeter, while this is kilogram millimeter square. Okay, so now we need to choose a reference plane. If you choose the first as the reference plane, if you choose the first row here as a reference plane, it means those unknowns will still be there. We still have four unknowns. If you choose the second one, those four unknowns will still be there. The same thing the third and then the fourth. So it means we have to choose a reference plane between 5 and 6, such that if you choose a reference plane between 5 and 6, it means if you choose 5 as a reference plane, it means we are going to have 5 as 0. Okay, but if you choose M6 as the reference plane, it means M6 here, this row here is going to be 0. Okay, so this is 5 and then this is 6. So but if you choose 6 as the reference plane, it means we are going to have more negative values. We are going to have negative values because to the left of 6 is negative, to the right of 6 is positive. But if you now choose M5 plane as a reference plane, it means you have few negative values. It means to the left of 5 we have negative, but to the right of 5 we have positive. It means you choose a reference plane such that you have few negative values. So that's why the best reference plane is going to be M5. So that is why here we are going to have 0. So since this point here is 0, so it means since M5 here is 0, to the left of 5 we have 300. So that means M1 is going to be 300, and that is negative 300. So that's why on the table here we're having M1 as minus 300. Okay, so the next one is M2. To the right of 5 is going to be 300 as well. So that's why we have 300 here for M2, for plane 2. The next one is M3. To the right of 5, from here to this point, is going to be 1008 minus 300. Since from here to here is 300, so we have 1008 minus 300. So that's why we have 15 here. So the next one is M4. Okay, so that is from here, from the reference place M5 to 4. So that's going to be 2004 minus 300, and that is 21. So that's why here we have it as 2100. So here the next one is going to be 0 because that's the reference plane. The next one, which is M6, so that's going to be distance between M5 and then M6. But we know from here to here is 300. Okay, if from here to here is 300, from here to here is 300. We also know from here to here as 300. Okay, so but from here to here, from here to here is 18. So 1008 minus 300, we are left with 15. So it means from here to here is 15. So 1005 plus 300, that's 18. So that means from the reference place M5 to M6 we have 18. That's why in the table here we're having this place as 18. So for us to get the last column here, we have it as MRL. The unit is kilogram millimeter square. So all you need to do is you are going to multiply this times this, we get this. 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 This times 0, we get this. And then this times this, we get this. So now that the table is complete, we are going to use this last column here to have our couple polygon. So but before we get our couple polygon, we need to choose a convenient scale. Okay, so now the highest number here is obviously we have 60 exponential 6 here is the highest number here. Okay, so you can start choosing your scale from here. You can take 60 exponential 6 equals 10 centimeter. You only need to choose any convenient scale. You can make it equals to 6 centimeter. So it means if here is, or let's make it 10 centimeter so that it will be larger. So if here is 10 centimeter, automatically that means 1 centimeter is going to be 6 exponential 6 kilogram square. Okay, so if this is our scale, so now the first one, which is minus 6 exponential 6, so it means minus 6 exponential 6 is going to be minus 1 centimeter, and then 10.5 exponential 6 is going to be 1.75 centimeter, and then 60 exponential 6 is going to be 10 centimeter, and then 52.5 exponential 6 is going to be 8.75 centimeter. So using this scale. So now we'll move to the couple polygon.